Welcome to qnawire.
For this problem on the topic of particle physics, we have a neutral K meson with rest energy 497.7 mega electron volts, moving in the positive x direction with kinetic energy 225 mega electron volts before decaying into a positive and negative pion. Each move off at equal angles above and below the positive x-axis. We want to find the kinetic energy of the pi plus and the angle it makes with the positive x-axis. Now, the kinetic energy comes from mass difference and momentum is conserved. We know that the magnitude of the y component of the positive pion's momentum is equal to the magnitude of the y component of the negative pion's momentum, and the positive pion p pi plus sine theta is therefore equal to p pi minus sine theta, which means that the momentum for the positive pion is equal to the momentum for the negative pion, which we can simply call p pi. And we know that the mass of the kaon, mk times c squared, is 497.7 mega electron volts. And for the pion, m pi c squared is equal to 139.6 mega electron volts. Now, conservation of momentum for the decay gives the momentum for the kaon equal to 2 times the x component of the momentum for the pion, and if we square both sides, we get pk squared equal to 4p pi x squared. And so we get pk squared times c squared is equal to ek squared minus mk squared c squared. And so the kinetic energy ek, or the energy of the kaon, is equal to 497.7 mega electron volts plus 225 mega electron volts, which is 722.7 mega electron volts. So this means that pk times pk squared times c squared is equal to 722.7 mega electron volts squared minus 497.7 mega electron volts squared, which is 2.746 times 10 to the power 5 square mega electron volts. And for the pion, we have p pi in the x direction squared times c squared is equal to 2.746 times 10 to the power 5 mega electron volts squared divided by 4, which is 6.865 times 10 to the power 4 square mega electron volts. Now, conservation of energy gives us the energy for the kaon is equal to 2 times the energy for the pion. And so the energy for the pion is half the energy for the kaon, which is 361.4 mega electron volts. Now, the kinetic energy for the pion is equal to the energy E pi minus the rest energy M pi c squared, which is 361.4 mega electron volts minus 139.6 mega electron volts which is kinetic energy of 222 mega electron volts. And so we have P for the pion squared times C squared equal to the energy of the pion squared minus the rest energy m pi C squared all squared. And this is 361.4 mega electron volts all squared minus 139.6 mega electron volts all squared. This is 1.11 times 10 to the power 5 mega electron volts all squared. Now the angle theta that the velocity of the pi positive particle makes with the positive x-axis is given by cosine theta equal to the square root of the x component of the pion's momentum squared times c squared divided by the momentum for the pion squared times c squared. And so this is the square root of 6.865 times 10 to the power 4 divided by 1.11 times 10 to the power 5. This gives the angle theta, if we take the arc cosine at the right-hand side, to be 38.2 degrees.